All right. Good evening, everyone, and welcome to Middlesex University. For those of you who are joining us from the external world, and welcome those who are our students. I think we have a good mix of different programs. So I think data science students are here, the cloud students are here, some UG students are here. So welcome everyone on behalf of Middlesex University, Insights Lab, and Microsoft Reactor. It is really an interesting day because always the quest of the university is something to tie as much as possible with the industry and bring the best experience for our students. And nothing amazes me more when the corporate entities, they themselves are excited about coming and giving back to society, interacting with students, which is something which Hussam and I have been trying for some time. For a wonderful partnership with Microsoft Reactor. They are doing amazing work in the entire space of AI, data science, cloud, and several other interesting topics that they are working on. I believe this particular session will be a start of a great relationship between Microsoft Reactor and Middlesex University Dubai and Insights Lab to bring as much as industry-driven content as possible to our students, for the community in general. For those of you who are not aware of Insights Lab, we are an entity that regularly interests in bringing corporate data, working on open data sets. We have done some wonderful hackathons in the past with public RTA data, Dubai taxi data, food safety hackathon, several initiatives under the campaign. And the response have been tremendous. As you can see, the response is great today. We have so many those who are attending this in person. And let me just take a quick count, more than 35 people who are attending this online. So close to 100 plus registrations, which is fantastic. We have not just one, but two amazing speakers today from Microsoft. We have Henk Berlman and Daron Yondem, who will be representing some wonderful topics in the space of AI, cloud, serverless computing, etc. But to start the proceedings, I would want to invite Hussam, who has been the backbone for taking this lead, for coming up with this initiative. Hussam leads the Microsoft Middle East and Microsoft Reactor Middle East and Africa, which is a hub for founders and developers to meet, learn, and connect. Prior to this, he worked on several capacity building programs and initiatives aiming to enable youth developers, aspiring founders in the UAE. His initiatives have received top awards from leading organizations, and you'll be happy to know that he's also featured in the Forbes Middle East 30 under 30. You are under 30? Wonderful. So right age to get that award. Wonderful. We are very, very fortunate to have you, Hussam. And I want to invite you to start the proceedings, tell us the rules, and invite the speakers as well. The stage is all yours.
Thank you so much for this warm introduction. And we're so glad to be here in front of you. As Dr. Krishnadas has mentioned, the partnership and the conversation started a while back, and we were keen to find ways where we come together to talk about the developer topics, ecosystem in general. We are at the Microsoft Reactor hubs around the world. In this region, we have a reactor in the UAE, which is focusing on the Middle East and Africa, because lots of what we have been doing for the past 2 years has been virtual. And we recently started coming back into an in-person operation, but we kept that online element still there. So today, for example, on this visit where we have a senior cloud advocate and a great also Microsoft also team member who has been an RD for many years, and I will come into an introduction in a bit about our great speakers. This was a great opportunity to come together in person in some tech hubs, in some universities like Middlesex universities, to share with you what is happening in the AI serverless sort of topics as well. So we are not just doing one session today, we're doing two, and we're aiming to merge all of these two great topics into a very also short period of time. We will have a break, maybe somewhere in between, maybe towards the end. But again, coming back into what we're doing in the reactor, we're a hub for founders and developers to meet, learn, and connect. We used to have a physical space only, and this is around the world. This is where the developers like yourselves and people who are having ideas and startups that are working on used to come together to work, to learn from Microsoft and from the partners, from the open source community, all about what's happening in the technology scene, what are the recent advancements, tools, etc., that they can use into their projects. Now, this is happening online, and it has been like that for 2 years, and we have grown a great community across the Middle East. So if you haven't yet been part of our community, this is an open community. The main group is on Meetup. You can just go to meetup.com or look up for Microsoft Reactor Middle East and Africa and be part of that growing developer community. I'm sure you have received it either on email or some other forms, but if you haven't, feel free to reach out to me or just look up for the name on meetup.com. Be part of that group. There are lots of opportunities to stream online, be part of these sessions, or actually attend one of those in-person activities. So again, coming to today's session, it was originally just about AI, but we were fortunate also to have another great speaker visiting us. So Henk is visiting us from the Netherlands, and he flies tomorrow night actually back to the Netherlands. So this is one of actually the last engagement we're doing with him this week. We have been busy across the city doing different engagements and speaking and workshops. And Henk comes with a wealth of experience around the topic of AI. He's a senior cloud advocate specializing in that area. As I said, based out of Netherlands, but he's an international speaker working in the cloud advocacy team at Microsoft, where he speaks to developers like yourself across the region and across the globe about what's happening in the AI space. So if you have questions during the session, whether you're streaming online or you're attending in person, he's the right person to ask. He's the right person to pass on your comments, because also he works closely with the product teams who are working on these great offerings that Microsoft has for you to use in your projects. And also, we, as I said, we were fortunate enough to have a second topic added to today's agenda. So Daron comes with a wealth of experience, 17 years as a solution architect, team builder, and an engineering manager. He was a Microsoft Regional Director, which is a prestigious title that Microsoft offers certain people around the group. It's a very selective program, and he's been a regional director for 13 consecutive years. Not only that, he also was a very hands-on developer, sort of advocate as an MVP. And an MVP also is a title given to those who are delivering great sessions to developers like you on what's happening in the technology space. So his focus is on serverless, DevOps, IoT, and he recently is joining the Microsoft team as lead for the Middle East and Africa for Azure application development. So yeah, that's pretty much the introduction. A quick reminder, I mean, if you have been to any of the Microsoft events, we like to keep it friendly. This is an open environment for all to ask questions, interact, be friendly. So let's keep it friendly environment, respect each other. These are the 6 major points where, be aware of each other, friendly and patient, welcoming and respectful, open to all viewpoints and questions, understanding of each other's differences and kind, and considerate to others at all time. So again, for those who are in person with us today, feel free to ask questions. Let us know in the chat. If you are watching this online, you can let us know your questions, and I will be on the production side in the background, making sure that the speakers get your questions. So I think that's it. I would like to ask Hank to join me on stage and to start the first session. Thank you, Hank, for joining us.
Thank you. Thank you for the introduction. Let me start with sharing my screen in the Teams call, right? So let's start with that. So we're here. Is it working? Perfect. Cool. Hello, everyone. Good evening, and thank you so much for joining in such a big number here at the university. So I have around 30, 35, 40 minutes to talk to you about the AI on the Microsoft stack. So this session is going to be an overview of what is all available, because we have a lot, and I hope to show you some cool demos so you can actually have walk out of this room and have an idea of, oh, I can do this with AI in my software right now. So my name is Henk Boelman. I'm a cloud advocate based in the Netherlands, but you already knew that. So my job at Microsoft is to talk to you all, and hopefully I find people that are actually working with our software or have already built something or have an ambition to build something, and bring feedback back to our product teams that are based out of Seattle that are actually building the products. And my job is to kind of help you build something really cool. So let's start with some numbers to show you how big this AI space at Microsoft actually is. So can you read the numbers actually? Or shall we turn the lights a little bit off? Better? Yeah. Because it's a big numbers, you should all be able to see them. So there are 28 billion requests per month to our AI service, to the models you all build yourself. We are not even building them, you are building them. There are 24 billion requests a month to the models we actually build. And I will show you later which models that are. And there are 4 billion messages per month going through our Azure bot service. So that is a lot of messages. So let's have a look at a few common questions companies have or problems you might have. The question could be I want to look into deploying and managing machine learning models at scale. And I find it quite hard to do in my organization. Where do I start? So for that, we have our Azure Machine Learning platform. This is the platform where you can build everything yourself, but we will help you manage the underlying infrastructure. So we help you take care of your data. We help you to take care of to train your model and scale on our clusters. We help you to make it secure, to help you make your models fair, and we can deploy them for you in production and make them scalable for everyone to use in every scenario. So this is the layer where you have to do a lot of things yourself, but in our safe environment. Sometimes you just want to have models or endpoints that already do things. So my team needs high quality pre-built models for common tasks, common cognitive tasks. And what do I mean with common cognitive tasks? You just want to look at an image and you want to do OCR. You want to do text to speech. You want to look at an image and see, hey, there is a bird, there is a car. Those problems have been solved. That is not something you actually have to start building using Azure Machine Learning anymore. Those services are there. You can just send an image and you will get back your result in JSON. And that is called our Azure Cognitive Services. And then even you might want to just modernize some common business scenarios. So these are raw APIs that can do one single task. And Azure Applied AI are services we build on top of those APIs. So a good example is, for instance, our Azure Video Analyzer. This service can look at the video, extract people's faces, can extract key phrases, can look at sentiment in certain places like, hey, these from 1 minute to 2 minutes, this person is really sad. And you can do that. It can also translate your video in other languages, generate captions. So it can do a lot of things out of the box for you as a single service. And also as a form recognizer. You can process lots of forms. It can look at all your invoices, extract all the data from it, and put it in a search engine for you. And all those services that you see here, you are using multiple of these APIs here, which probably have been created using this. So if we look at the complete landscape, this is it. We have the machine learning platform to start with. We have our customizable AI models, because our cognitive services are APIs. But sometimes you can customize them a little bit so that it caters to your need. Then we have the AI applied AI services, and that are scenario-based services. And we use them in our Power Platform or in the applications like Microsoft Word and other things in Excel and Microsoft Dynamics. And a lot of our partners use the services here. So let's zoom in to the Azure Machine Learning Platform. I'm not going to take too long to talk about this one, but what it can do is manage the complete lifecycle of your models. And that helps you to improve your time to market. You don't have to take care of all the underlying infrastructure. You don't have to take care of setting up your own GPU labs, computers in the basement of your university. No, you can just use Azure. It helps you to make your models operational at scale. We can scale your models. We can scale it to 1,000 units. Doesn't matter. It can scale out. And you develop it on a secure and hybrid platform, making it compliant with most of everyone's regulations for machine learning models. Because some models you have, some data you have, you don't really want to always have it in the cloud. So this can be also hybrid and be connecting to your local data centers in your university or in your company. Fancy animation here. So I'm going to go and continue to our Azure Cognitive Services. Because Azure Cognitive Services are a really great way to start with implementing AI in your solutions. So they're divided in 4 regions. So there is vision, to make your application see. Speech, to make your application listen and talk back to you. Language, to understand what is being spoken. And decision will help you make certain decisions based on events. So let's have a look. What is all there? So cognitive services are customizable, pre-trained models. What do I mean with that? So these models, these APIs, are trained by us. So we have kind of a base model. Let's take a look. We have computer vision. That API you can send data to, and you will get a response back. But sometimes it doesn't really classify what you want it to classify. So you can bring in your own images, retrain the model so that it recognizes your images, and deploy that one as an API. You still don't need to know anything about machine learning, except that you have to give it good and reliable data, because otherwise it will not predict very well. But that is what we mean with customizable pre-trained models. You can deploy them anywhere. So we can deploy them in all our data centers that cover the globe. But you can also pick some of these models out of Azure in a container and deploy them in your own data centers. So that these models run very close to where kind of the action is. Or if you have a disconnected scenario where, for instance, you're on a cruise ship and you don't have a reliable or a big internet connection, you kind of want to have the model do the work here instead of sending 1,000 images to an endpoint and then takes a minute for the response to come in. You don't want to have that. The thing is, they need to still have connection to the cloud, but they only send a few messages back to Azure telling about the billing information, because of course you will be billed exactly the same way as that you would be billed if it runs in our infrastructure. This one, no machine learning expertise required. Well, a little bit of machine learning expertise is required because, of course, you need to know if you want to customize it, which data you're going to give it. And if you give it crap data, you will get a crap result out. And of course, we developed our models according to our responsible AI principles, so that you can be sure that it is responsible and very well tested. So let's dive into cognitive services, what is available. So we have language, vision, decision, and speech. So language, we have, for instance, the text analytics service. To that service, you can send a bunch of text, and it will return a lot of insights about the text. It will tell you, hey, this is very negative text. It will extract like key phrases out of it. So if I'm talking about the Eiffel Tower in Paris, it will recognize, hey, there's an Eiffel Tower, it's Paris. And if I say the food was nice, then it will recognize that it is a very nice sentence. And that is, for instance, very handy if you have a Twitter feed and you want to monitor like how people talk about your company. You can run all those tweets through the text analyzer, and it will calculate the sentiment for every sentence. You combine it, and then you see, oh, everyone is very happy about my company or my brand today. That is vision. We talked about computer vision and custom vision, but there is also a face API, and it helps you detect and identify faces in images. That is speech. That will do obviously text to speech and speech to text, but there is also a service called speaker recognition, which you can train so it can recognize your voice or someone else's voice and actually take action if two voices match, if your voice profile matches, and you can use it for authentication. And finally, in the piece, the part of the decision, we have an anomaly detector that can detect anomalies and time series data, and there is a content moderator and a personalizer. Service available. So let's go to a small demo where I'm going to show you some of these cognitive services in action. Let me find, I have now too many windows here. So let's take a look at some vision services. This is a Jupyter notebook because every service comes with a software development kit, an SDK, and which you can use in the language of your choice. They come in C#, they come in Java, they come in Python. So I chose to use Python, so I can use a notebook, which is actually very easy to demo the capabilities of these services. So I'm starting with importing a lot of dependencies. And after that, I'm going to create a resource group. Everything in Azure needs to have like a resource group, a bucket, and probably I have to re-authenticate myself. No, perfect. My token was still valid. If not, you had to use Azure login. So the Azure CLI is a tool we have that you can control whole Azure through the command line. So you don't have to go to an interface, click, 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 click. You can create everything you want and manage everything you want through the CLI, which is really great because then you can have it in code and can document it. So I've created a resource group called Accessibility Resource Group. The next thing I'm going to do is to create I will run it first and explain what it is doing. I'm going to create a cognitive service endpoint of the type computer vision. And then I'm going to ask me, give me the keys and show me what the endpoint is. So I have my key, and now I can use my key in my computer vision client. So I'll run it, and now I have a computer vision client object that I can use to start sending data to the computer vision API. So now I can have an image, and that is beautiful Amsterdam with a lot of stuff on the image. You see, it is quite a busy image. There is a lot going on. And let's have a look what the API says if it looks at these images. So it makes a description and it tells us, hey, I see bicycles parked on a bridge. And that was actually true. But it can do more. It can tell us actually where objects are. It sees a tree, it sees bicycle wheels, it sees bicycles. It doesn't see everything, but it sees a lot of things on the image. But then we run this image through it. And here we see a common problem that we can have with this API. It is detecting a person, and that is correct. But is that actually what I wanted it to detect? No, I wanted it to be detecting a banknote. So what I can do for that is I can train my own model using the custom vision service so that it will be able to detect banknotes. So let's start and do that. So first of all, I will create an endpoint and get again a key to use that endpoint. I'm going to create a trainer object, tell it where my data is. So what I have here is a bunch of banknotes. I have like 200 nodes, 300 nodes. I have a small data set that I'm going to use it to train on. I have 50 nodes and so on. So I have a few of those images. I'm going to create an endpoint, a trainer, and the next thing I have to choose on top of which model am I going to build this, my own classifier. Am I going to use a landmark model or a food model? And all this is of course described in the documents what it really is and on which model it is actually based. So what we are going to do is we are going to use a general compact model. If the word compact is behind the domain, you can later on export the model. So you can use it in TensorFlow ES, or you can use it on your own, on your iPhone in CoreML format, or Onyx, so it can run almost everywhere. So let's do that, and we're going to create a project here. So I've already done this because this takes like 10 minutes, and nobody wants to wait 10 minutes. So I'll talk you through it. So we create a trainer. I will give you an insight in the data set, so we can see it all. This is the data set, a part of it. And then we start uploading images in batches. So 64 by 64 by 64 images, we're going to upload it. And then we're going to say train. When we're done, we wait for it for 10 minutes. And when we're done, we can start exporting the model. We choose the flavor, so we want to have Onyx here. And then we can actually say, give me the exports and get them as a zip file. You can also get it wrapped in a complete Docker container, so you can actually deploy it in your own infrastructure. And the cool thing here from is that you don't need a connection to the cloud. You will get that model for free and that container for free. So I'm now connecting to an older run, which I have already done, and I'm downloading the zip file. And I'm going to extract that zip file, and export is not supported. Why not? Request export, get download URL. Yes, please. It worked yesterday, you saw it. Let's say, while exporting, exporter. Quickly download it. You can have the project ID from the trainer. Because if not, I can show you it in the interface. There are no exports in. That is a shame. Okay. So what I will show you is I will show it to you in the visual interface, because there is always a visual interface if you are stuck. Customvision.ai. So everything I did here using the command line by uploading the images, you can also do in the Custom Vision website. That's called customvision.ai. You agree, you log in, and here you will see all your projects after a while. After a while. Now would be a good time. So it's still loading, but let's assume that it is this project. So here on the left, we see all the images uploaded. And here we see all the models that have been trained. And here is the export button. And here you can choose the different flavors. So I wanted to have an Onyx file. You can click export and it will give you the model, which later on you can use. So let's do a quick test and see if the model can now detect our banknotes. So here we have test images. I have a banknote of 50, and here we see it is able to detect the 50 note. So that is custom vision. And we can go more. So the next thing I wanted to see, let's show you how easy it is to detect faces in images and describe them and get insights about that. So I'm going to create another endpoint in Azure, get a key, use that key in my notebook, create a phishing client. You see that most of these APIs and these SDKs work almost the same way. So we have here an image with my Tech Ally Summit crew, and we're going to take a look at who and what is happening on this image. So here we go, and we see here is my first friend with a very nice face ID. It's detected the person's gender, if the person is smiling, the age, if there's facial hair, if someone is wearing glasses. So here we see this person is wearing glasses. This API can detect if you're wearing reading glasses, sunglasses, or swimming goggles. If someone is wearing eye makeup, and it will do a guess how happy or how pissed off someone is. So this person is very happy. But now we still don't know who those persons are. So what we can do is we can customize this API a little bit by training it with some people. So I have here a bunch of images, the other images of those 6 persons. So I can give that to the API, tell them, hey, this is Floor, this is Henk, this is Roland, and let it use that information to tell on other photos, hey, this is Henk and this is Floor. So let's train it. So the first thing you do is you create a person, and then you can start adding pictures of faces to that person. So when you have done that, you have to train it, and it takes only like 10 seconds. 10 seconds to do that. And then you do this exact same thing. You ask, hey, detect all these people in the images. You get those IDs. And now with those IDs, you can look them up in the face table, in the face group, what we are doing here. So it has found the people, and now it can draw those names on the image and recognize these people. So you can add like more than 10,000 people to one of these face groups and have your own face recognition system. So the next part, I want to show you a few examples from our Azure Applied AI services. So we talked a little bit about form recognizer, the bot service, the video analyzer, and the immersive reader. So if we take a look at these slides, we see the six services that we offer. So cognitive search is a really cool search engine that you can customize to your needs. So remember when on Google you ask what is the capital of Paris, what is the capital of France? It will tell you the capital of France is Paris. So that is what you can do with cognitive search but then on your own data set. So you can load in a bunch of data, enable semantic search, and then you can ask those questions about your data to the search engine. While the search engine is indexing, you can also connect it to a different bunch of cognitive services. So you can connect it to the form recognizer, so it extracts all the data from your forms. You can connect it to the computer vision. So if you upload a bunch of images in your search, it will run it through the computer vision API, extracts all those insights we saw with bikes and trees. And then later on, you can ask your cognitive search, hey, I want to see some pictures of trees. And then it will automatically filter it out for you without doing much work. So let me show you a demo of Azure Form Recognizer, because that one is really powerful. So this is our demo environment. I will zoom in a little bit and then zoom in a little bit about the document. So this is a sample invoice. It has like the lines on with descriptions, quantity, amounts, and it is in English. So I'm running this through the analyzer. And what it does here is it extracts all this information from the document. It tells us, hey, this is the billing recipient. This is a description for this is the invoice line. This is the description. It is about the unit is hours. This is the subtotal, and it can do that all out of the box. There is also a possibility to customize these models, so it can recognize your own documents a little bit better. But out of the box, it was really ready to, no, not this one, to recognize my Dutch invoice. So here we are, it is all in Dutch, it is taxes and Dutch words, maybe with dates. So we run the analyzer on it. And in a while, it will tell us where the invoice number is and what it is and where these lines are, what the total amount is. And the cool thing is that it shows all the fields here, but also the results will be available in JSON, because this is still underwater at REST call with the document to an API, and it will return a bunch of JSON with coordinates and labels and fields. And it generates a bunch of code for you, which you can actually use and customize in your applications. But here we see it is also working on some Dutch documents. So the last thing I want to show you is video analyzer, Azure Video Analyzer. So I've uploaded a video, it processed my video, and it extracted a lot of insights from that video. So here we see it has detected all these people. It will tell me exactly when they appear in the videos. It is extracting like the main topics, what it is about, some audio effects, and I always like this piece. It is showing the emotions in the video. So here, someone is actually very sad, and here someone with a lot of fear. Okay, doesn't look that good. It extracts all the keywords. Here it is about Africa, it is about a living room of Johannesburg, the Netherlands. So it recognizes all these things. But it also creates a transcript from your video automatically. And what you can do is you can translate that transcript to around 100 languages. So it is now real-time translating it to Arabic. And of course I have to log in again. That was expected. So I'm logging in again, going back to my video, clicking on it, asking it to translate it again. and it has now done it. So I translated everything to Arabic. And out of the box, I'm getting now also the captions available in that language of your choice. So you can go translate it into Spanish, adjust it a little bit, go to Portuguese and all these different languages, and download them, download the closed captions, and use it in other projects. You can actually import them back into YouTube and have it there. So I want to close off with this, with the 30 days to learn AI challenge. If you finish that challenge online, ak.meisjes/GI-challenge, you get a challenge where you go to like a few Microsoft Learn modules. That is our learning system at Microsoft. You will do the challenge. Basically, that is going to all the different cognitive services, answering some questions, and then they will email you a discount voucher for a Microsoft exam. And that is always good because I think it is around 50% discount. So that saves a lot of money if you want to do that. So you have 30 days to complete it from the moment you start the challenge or start the learning module. So that's it for me. I wanted to thank you for being here, listening to me. And what is the plan?
Thank you. Thank you.
Do you want to have a break now, or do you?
Take some of the questions from the audience.
Okay.
And then we will cover a few questions. I have like 6.
I can switch to my desktop.
Let me remove my desktop.
6 from the online attendees.
Okay.
So, yeah.
Perfect.
All right, so let's open questions here. If you have any questions.
I'm gonna take it. This is yours.
Yeah, I'm going to take it.
Thank you.
I have it here.
Our first question.
I want to ask you, thank you for your presentation. And like all the services you just explained. So in terms of helping out figuring out the data or normalizing the data, like what score is available in terms of that? For example, all of these services will require the data to be in a specific format or in a specific form, right? So what kind of support is available in that?
Yeah. So if you use Azure Machine Learning,
Yeah.
So if you use our Azure Machine Learning service, you have to do that all yourself. You have to prepare your data, which you can use all the open source tools step by step. If you use cognitive services, it doesn't really, let's say computer vision. There is a specific format you have. It has to be a GPG or a PNG. It doesn't take like a PDF. So it is an API, so it is specified which things you can do and you can't do. So that is all available on docs.microsoft.com. You go to the specific cognitive service and you see what the input is. They don't actually really train on your data because the models are mostly trained those cognitive services. So you don't have to filter in your data. It's only the inference part that you actually do. For the computer vision, for the cluster vision service, which is all me uploading those banknotes. For that service, it does most of the data processing for you. So you don't have to start scaling images and flip colors and rotate them. It will all be done in the background for you. It just needs 50 images per class to work correctly. And if you want to do object detection, you will have to deliver a set of labeled images because you still need a label data set. So I'm not going to figure that out.
Send me the things that they use.
You're welcome. Very loud here.
Loud or low?
It is very loud behind the door, so I can hear.
And there was one slide where you showed like an invoice and like the different boxes. Is that for Oh, is that for OCR? Is that for companies to automatically post their invoices? What's the use of that one?
Yeah, that is actually designed to process like a lot of documents.
Yes.
What I showed was in the invoices.
Yes.
And of course, some companies have a lot of invoices.
Yeah.
So you upload them to a file share, and the AI will pick them up, put them in your system automatically. It can also be for IDs. So you make a photo of an ID, extract all those features from and puts it in a database for you, so you don't have to find all the names.
Is it only OCR or does it also do checks and comparisons amongst the data?
It is not only OCR, because it is, of course, a combination to extract it, but to map all those fields to the right things, there is an AI model behind it.
All right, perfect. All right,
And you can customize that model to so if it doesn't really recognize your invoice,
yes.
you can give it a few samples, retrain it,
Yes.
and start recognizing your documents better.
Thank you.
I think we better answer the questions from here, so that also our online attendees can hear us.
Okay, they can't hear it from here?
I'm not sure. I think they lost some part. So I think at least when you respond, maybe from here. Any more questions from here, or shall I address the online ones?
Yeah, try to address online.
All right. I'll start with the freebies. How can we get like Azure Credits and free access to use the services?
Of course, the question to ask. So you get, when you sign up to Azure, always free credits for the first time. So you go to azure.microsoft.com, you click on Start for Free. You get $200 that you have to use within a month. I think, I don't know how the local currency is, but it will convert to somehow the same. We get like 180 euros in Europe. So you get an amount of free things. There are also some cognitive services that you can try for free to see how they work. And even if you have an Azure subscription, you have to have a credit card. Most of these services don't cost any money. If you don't do like thousands of calls in a day, if you do like 10 calls in a minute, then there is for all these services a free tier, so you can actually try it. So you have to sign up, you get free credit, and then you can use it for free. So, seems like a good deal.
Awesome. All right. So I have a question about from Noor asking about the translation of videos. Does it translate each word or the whole sentence, as the demo was showing?
It looks at the whole sentence.
Yep. Okay. For the challenge, does it have to be 30 consecutive days?
No, it is like one challenge, and it has to be completed within 30 days.
Okay.
So you can do it, I think it takes you like half an hour to do it. But you have to be done within the 30 days.
Sounds like a manageable task.
And otherwise you get a lot of emails if you don't.
Okay. Can people, for example, students from business information systems or any also other domains, let's say, manage to use these features and services without knowing much how to program?
Yeah, you can. There are a lot of like the applied AI services. You don't really need to know the things, but they're also, for instance, available in Power Apps or in Logic Apps, and that is kind of a drag and drop interface to kind of do things. So you can drag and drop the interface, like, hey, if there is an image here arriving on this blob storage, call this service and write that in this text texture, and then you have the result there. So you don't really have to program, you just have to basically understand only the steps you need to do. And there are a lot of cool tutorials, so that is really an easy way to get started with Azure, with AI, and kind of a little bit of programming, but very visual.
All right, and the last one, most of the other questions we have already covered. The last one was about a recommendation. So Joe is asking, which language would you recommend focusing on for like more advanced AI sort of implementation? Do you suggest Java, Python, or what else?
Depends on what you want. If you want to implement these services, then you can choose any language you want. If you want to develop your models from scratch, then you're bound to training frameworks. So, and they mostly are available in Python. So if you want to train your models in PyTorch or TensorFlow, then like the main choice and the mainstream will use Python to do that. There are some services for ML.NET where you can do also a lot of things, but not really deep learning at the moment. It's mostly the classic machine learning tasks that you can do. So it depends on your problem and on what you want to kind of achieve.
Thank you, Hank, for the session today on behalf of the students and also behalf of the actor. It's been a great week with you, and we've done lots of interesting sessions. So we look forward to having you again in the future here in the UAE. And now, yeah. We're moving on to the second topic of the day, Azure Functions and Serverless with Darun. Darun, the stage is all yours.
Yes, sir. Thank you. How you doing? All good?
Yes.
I'm sure you don't know this, but I am the only thing between some pizza and food and yourself. I'm really sorry about that, but you know, keep your eyes on the price. Think about the pizza. This session will end. I'm gonna have, how many minutes do I have? 30, 40?
More or less, yeah.
More or less? Okay, cool. So I will talk a little bit about functions. So this slide deck is a little bit large. So I'm gonna go through all of it. Before I actually start, let me ask you a couple of questions. Who built anything, something on Azure? Okay, cool. AWS, GCP Cloud. Okay, good. That's what I expected. Okay, good. So do you have any ideas why we need cloud? Why do we need cloud? Why does this thing exist? Storage?
To reduce the cost of infrastructure spent by the company.
Cost of infrastructure spent by companies, but okay. Scalability and interesting. Okay, anything else?
Convenience.
Convenience. Is that what you said? Okay, cool. Anything else?
Sharing of the cost.
Sharing of resources. Okay, that sounds like a little bit scalability as well. But I think what you mean is kind of having a single pool of resources where you can have multiple tenants. And by tenants, I mean maybe customers or multiple applications, right? So think about it. You have, let's say you have two apps. You know for sure that one of them is being used a lot during rush hour. And you know for sure that the other one is being used a lot during lunch hour. And both of these apps, they require two servers to run. Just go with some number, example number, right? So what are you going to do? So most probably you're going to buy two servers for your app number one, for the rush hour app, and then another two servers for the lunch hour app, and you're going to run those. And you end up having four servers. So what if I could use just two servers? During the rush hour, I would have my rush hour app, and during the lunch hour, I will have my lunch hour app. So if I could do that, I would be saving from 50% of the capital investment I would require, right? Just to get things out of the door, right? How many people are university students in this room? Okay, cool. So you guys, you might have startup ideas. I'm sure you do, right? Or you're building some kind of a mobile app, and then you're putting it into the store, right? You're publishing into the store. And then what if really all of Middle East, you publish the app today, and tomorrow morning, or actually, let's say, you published it today, and while you're asleep, everyone in China went crazy, and they decided to use your app. Okay? So I'm assuming you're not publishing apps with the assumption that no one is going to use it, right? So someone will use it, and while you're sleeping here, China went crazy. Your app is beautiful. They started using it. But your app had a registration form, and obviously the registration form talks to some kind of backend, right? You have a server. And all China is coming to register. How are you going to handle that? What is your server is going to do? Crash. Why? Because you didn't plan for it. What could you do if you planned for it? Would you just go and buy 50 servers? No way. And that was the scene like 20 years ago. If you wanted to launch a company, we couldn't do it, right? We couldn't do it without a huge investment. We didn't need it as well because, you know, think about it. Today you can build a mobile app and get into a store, either Apple or Google, doesn't matter, or Microsoft. You can get into a store where you can access all China while you're asleep. Like millions of people, you're getting in front of a market where there are millions of potential customers. That was not possible 20 years ago. So one interesting thing to think about is, you know, most of you are developers, right? So let me ask you something. Let me get internet out of your hands. There is no internet, okay? And let me ask you this. So actually, let's think, if we didn't have internet, right? Think about an app that will be used by 2,000 people. What would that app look like? Where would that be? 2,000 people using a single app, no internet. What? Definitely there's going to be a server, which kind of, you know, makes us think like there's going to be some kind of a network for 2,000 people to use an app. There's going to be some kind of a network, but no internet. So 15 years ago or 10 years ago, this was the situation. And where do you think 2,000 PCs would be connected to a network where there wasn't internet? What type of organizations would do this? Finance, like army, right? And so my other question is, how many years of experience do you think they would require before you can step in and start changing the code of that app that serves 2,000 clients? 2,000, you know, employees in the organization, right? How many years of experience do they require? A lot. Quantify it. Tell me something. 5, 10? Okay. So today, when you are building a mobile app, you are getting into a marketplace with millions of people. And we are expecting no experience at all to be able to do it. That's the expectation of the industry, right? When you are building a cloud app, when you are building a startup, you are actually building an app that will serve potentially, again, we're not building those apps so that no one uses it. That's not our assumption. So potentially millions of people will use it, and that's expected, not even before even graduation, right? That's what we want to do as well, right? When we are running startups. So this problem is huge, and cloud is the solution, kind of democratizing the problem of distributed transactions. Sometimes I call it distributed transactions, distributed computing. Is a big problem. It's not easy. So the cloud is supposed to solve that problem. But again, if we look at cloud today, it doesn't matter what cloud provider you go. When you go to a service, most of the time what you're going to see is they are going to ask you some kind of a scale unit. So you'll go in and they're going to say, hey, 3 CPU cores or 3 EVMs, we can scale it. They kind of automate the process of procuring new hardware for you. So if you had an app running on 2 servers and you wanted to add a third one, classically you will need to, submit a purchase order to Dell or IBM or whatever and wait 2 months for the device to come in. And then you're going to install the operating system, the framework, and all that stuff on it, set up the networking, make sure the disk is set up correctly, you got the right RAID set up, whatever, all that stuff. You have to know all that or have people in the organization know that. Okay. So cloud automates that process and does that, not just for you, for a lot of people. And that helps those cloud providers to have a pool of servers where you are simply, when you want to go to a summer vacation, you don't necessarily purchase a home, right? You go into a hotel and book a room for a couple of days and you're done. So that's kind of what's happening. But again, the problem is you are going with, today, most of the services, even though the idea of cloud was that, we will pay for what we use, right? If you look at most of the services, besides cognitive services that you're just seeing, you need to go and tell, hey, I'm going to use 2 servers with 2 cores, and that's what I want. When I have load, I want you to make sure you can automatically install my app into another server of 2 cores and scale my cluster. That's what they usually do. Most of the services ended up doing that, right? You have a cluster, a set of VMs, your application installed. They automate the installation of your app. They automate health checking your app, monitoring your app, making sure it runs on the new server. And they add new servers to your pool while you're asleep. So your customers in China are happy. But the problem is still your procurement unit is, either a server with a particular number of core counts. You decide how much it's going to be, 1 core, 2 core, 4 cores. But that's the billing unit. And that's not where we want it to be. Where this whole thing started, cloud started, the idea was that you really pay for what you use. And if you don't use, don't pay it, right? And as a developer for myself, I really don't care that in your physical world you have this problem that on a particular physical server, the maximum amount of cores you can have is 256. I'm just making up the number, but vertical scaling has a limit. There's a physical limit on planet Earth about the amount of cores you can have on a single device. So when you hit that limit, and by the way, you hit that limit sometimes because of financial reasons, because instead of having a 256 core server, it's much cheaper to have 228 core servers. So you want to do that instead of going up, right? Vertical scaling, horizontal scaling. So anyways, when I'm writing code, for me, I just don't want to care that because of those physical world limitations, you have to run my code in 2 servers. Then I'm gonna think about state synchronization or distributed transaction, that type of thing. I don't want to do that. Today, when I write code in C# or Java or whatever, what do you do when you want to save a file? Do you really care? Do I have a M.2 drive on this device, or do I have a SATA drive? No. Because the operating system encapsulates that complexity behind the scenes, and it simply gives you a logical file system, and you put your stream and you're done. That should be the same thing with cloud as well. And long story short, here's my pitch. Serverless is the solution. That's what serverless is. That's why the name is serverless. It is trying to push us away from servers as much as possible. Is it 100% there? No, we're not there. But that's the idea, and we are pushing. I mean, there is this this is a kind of funny discussion in the industry that serverless is what PaaS was supposed to be, and by PaaS we mean platform as a service, which is where this whole cloud thing essentially started or was supposed to be. So we wanted to have this ideal environment when all these cloud providers were building platform as a service offerings, but it didn't work. It didn't get to that direction because the development methodologies and all that stuff was not ready, and I will talk about that. But then we needed it, so we came up with this new concept saying serverless, which is a little bit higher level than platform as a service. We got infrastructure as a service where we simply got VMs and stuff and install on it. And we don't care about installing the operating system and all the underlying stuff. We don't care about the disk drives and so on and so forth. That's what infrastructure as a service is. Then platform as a service where things like the runtime comes in, the configuration for the runtime, the patching, updating comes in. And now we got serverless where I simply give you a function, a JavaScript function, a C# function. I give you a piece of code and I tell you, run it. That's all I want. I have a piece of code. I want you to run it. I don't want to care how many times you need to run it. I don't care how many core counts you need to run it simultaneously, like thousands of times. I don't care how many requests comes in, right? I don't want to monitor it or even know about it other than the end of month bill. So, but I don't want to do any of that. I just want to give you a code and you will run it for me. And I only want to pay as much as I use. So one interesting thing that you're going to notice, and the serverless concept in Azure, the primary runtime and the service is called Azure Functions, right? So Azure Functions is the runtime and the service itself. You can take the runtime, run it on your device, run it on your data center. It's not dependent to Azure. You can run it on Kubernetes, wherever you are. You can run Azure Functions on AWS if you want to. So the runtime is out there. So the runtime that is part of the SDK that you install on your machine as a developer is the same runtime that runs in the cloud. So this runtime if you look at the billing on Azure, which is kind of important when it comes to serverless, because that idea of, I'm going to pay for what I use, right? If you look at the billing, there's a unit called gigabyte second. That's a unit. What does that mean? You are going to pay for the amount of time your code ran, and for the amount of memory you used while your code ran, and that's it. So if your code doesn't run, you don't pay it. I'm done? Out of time? What is that?
You have the number.
Okay, I have another 30 minutes. Okay, thank you. I was like, no. Okay, cool. I have another 30 minutes.
Exactly.
Okay, great. That's good. So, what I was saying, you interrupted me.
I'm sorry.
So you pay for the memory and for the processor time that you use, and if you don't use anything, you don't pay for anything, and you're not provisioning anything. You don't have to say to the platform like, I need more resources. You don't say that, because it's event-driven scaling. What does that mean? Event-driven. So events, something is happening. Then the platform is deciding to scale. What can that be? It can be an HTTP request, right? An API call. A customer coming to your website is an API call, right? Essentially, it's an HTTP request. They come in, they request some HTML, right? So that's an event, right? So we scale, the platform scales the underlying resources based on how many events come in. It scales automatically up to how many servers that it needs. You don't have to care about it. Because at the end of the day, you don't care because you're not paying per server. You are paying for the amount of time your code ran and for the amount of memory you used. In that case, you don't have to care about how many servers you have to add or remove from your cluster and monitor. I don't have to monitor my overall processor usage across 5 servers and kind of decide on a buffer and add more servers or remove servers. No, I don't need to. Just events coming in. It can be an HTTP request. It can be a timed trigger event. It can be a trigger coming from a third party. You're going to listen for some event from a third party. You give them the endpoint, and you just wait. And while waiting, you pay 0 because you're not using any processor time. You're just waiting. That's it. So if the application that you publish today doesn't get used tomorrow, you pay 0. If all China comes in, you're going to pay for it, but at least they're going to be able to register. So you're not going to lose customers, which is very important. And I have this story from, let me tell you actually. So a couple of students, this is like a 7 years old story, by the way. So a couple of students decide to build an app that track public transportation, cars and buses or whatever, right? So the government agency that regulates those, buses, they actually put the GPS coordinates of the buses on their website as text. This is funny, right? Why would you put that as a text? Because they're a great government agency. So they put it as a text. So 2 students decide to crawl the website, right, every 5 minutes and put it into a database. They build a mobile app and they publish it on the store and they say, okay, depending to your location, I can do a query and tell you where those buses are. Brilliant idea. So the third day, they notice that there's a lot of load coming in and their application crashes. Why would that happen? Because they're in the news. And there are crashes. So think about it. If you download an app and it crashes, what do? You just delete it. How many times do you try? Just 2, 3 times you delete it. And what is the chances that you are going to reinstall it and give it another try? It's really tough. A friend of you should really say, oh, there's this amazing great app, and you need to be exposed to it another time with very positive reviews so that you give it another chance. So you are losing business if you're not using cloud. That's essentially what it is. Okay? So that's the solution with serverless. Any questions so far? Do we have any questions online? No? See? I'm doing so good. No questions. Either everything is very clear or you got nothing. So if you don't have any questions, then that's it. Okay.
So this is one of the type of tables that I really like in universities. You put your mouse and it slips because that's an angle table. Okay, anyways. So let's talk about a little bit, materialize the discussion a little bit. So what do we have? Azure Functions 101. These are the languages supported. That's it. Okay, if you're interested in any of these, you can use Azure Functions. Okay. So what do we use that for? Timer-based processing. This is beautiful because, I'm going to do something every 5 minutes, 10 minutes. And, I will only pay, again, for the amount of time I used. SaaS event processing. So I will be listening to a third-party system. They will do something and let me know. And then I'm going to do something and hand it over to someone else maybe. I'm going to be the glue between multiple services, right? Or multiple apps. I can be that because I don't really have to care about, how many times this app might call me or how many times I have to call someone else. I don't have to worry about the scalability of that issue. So that's beautiful. Full serverless architecture. Yeah, I'm going to build a full serverless app. I can do that. Real-time streaming, obviously. Real-time bot messaging. This one is an interesting one because if you think about bots, it's all about, request response. You ask something, you get something. And those are all events, essentially. So serverless is a beautiful fit. Serverless API backends is the mobile app scenario that I just described, right? You have a mobile app, and what you usually use is simply, a set of APIs as the backend. Build those as serverless, APIs and just deploy it somewhere. So you're safe. And you should definitely have monitoring, by the way, because like I said, if whole China comes in, at the end of the month, you're going to need to pay for it. So probably you want to know before at the end of the month, right? So it's good to monitor stuff, but at least, you're not going to lose customers. You can use it on public cloud, which means you can use it on Azure. Let me see if I have to skip this. Wherever you have Kubernetes, self-scale with self-containers, and it works on my machine. Yeah, billing model, we did talk about that. Authentication, let's skip that for now, and let's do a hello world. Okay, great. So I'm going to open Visual Studio, and you can do this with VS Code as well. This whole thing works on the Mac, wherever you are. It's not going to be a problem. I'm just used to Visual Studio. I'm going to say create new project. You can do all this stuff from CLI as well if you're a fan of it. It looks like someone is.
Yeah.
Okay, let me go. Function app, yeah, function app, whatever. And here, I have a couple of templates. I am going to go with the HTTP trigger template. Template means it's going to spin up a couple of lines of code for me, just, so that I can understand what's going on and get things running really fast. So I'm going to go with HTTP trigger because I'm going to build an HTTP API, right? So there's this thing called on the right-hand side, it says storage emulator. What is that? So the functions runtime uses a storage account. What does that mean? A storage account in Azure is storage. Because again, your app is scaling, right? And when your app is scaling, you're going to need to log some stuff, right? You need some storage because when your app scales, let's say, as the infrastructure scales, you have 5 servers, and then when there are no events, no need, those servers will be dropped. So you cannot necessarily save stuff on these servers. You can save temporarily, but those are, again, temporary, right? Because you don't know if the server will be used. It's not going to be. So you have to have a scalable central storage system. It's still going to be in the same data center, so you're not going to suffer any latency or anything like that. Think about it like a network storage device or something, right? So that's the storage thing that is about. There's a local emulator during development. You can use Azure Storage if you want. There are different, providers such as you can use SQL Server. And another thing that we do with the runtime does with storage system is when you have a timer trigger. One of the tricky things is if you scale a timer trigger, which usually you don't, but if you have your application on multiple servers and as part of your app there is an additional timer trigger, so there's a problem of having the timer run twice. Right? Every 5 minutes, if you have your application on 2 servers, it's going to run twice. So you have to have some kind of a central lock to ensure that it runs only on one server. So the runtime uses the storage system for that as well. So that's kind of the thing. Authorization, I will go with anonymous for now. I'm not going to go into that. You can find documentation on that. It's not a huge deal for now. So I will create a project, and this is going to spin out a hello world for us. And that's it. Let me zoom in. So this is essentially a C# function. I know that this looks like a lot of code. I'm going to explain what's going on here. But at the end of the day, this one is a function. We are decorating our C# function. This is a C# function. I'm telling the runtime that this is an Azure function as well, right? It's going to serve GET and POST requests. I'm not going to have a specific HTTP route for this. It will just go with the default one. The authentication for this one will be anonymous, which means there isn't going to be any keys or anything. You will straight be able to access to it. You can have different, authentication schemas. And then what else do we have? That should be pretty much it. And I'm getting the HTTP request as part of this function. So an HTTP request comes in, runs this C# code. This could be JavaScript or anything, right? And I'm getting the request. And if you look at the code, what it does is it is trying to get a name parameter from the query string, right? And it is trying to get the body and check if there is a JSON in the body and get the name from the body as well. So simply, I'm checking query string. If there's a name parameter, I will get the value. If there isn't, I'm going to go into the request body, look into the body, deserialize the JSON, get into a C# object, look into it if there's a name, and so on and so forth. That's all it. And then return an HTTP 200 message, which is an HTTP OK, with the response message, which is this text. Hello, someone. It's a simple hello world API. Okay, so when we look at the project here, and let me see if I have, give me a second. I should have it. There we go. Come on. OneDrive, please. Yes, thank you. Yes. And voila. Okay, great. So if you look at the project is pretty simple. I just have a C# file, right? And the function is in it. And that's pretty much it. I can have multiple functions as part of a function app, right? The function app is the scale unit, by the way. So you can have multiple functions working together. So usually, think about this like a container type of isolation. This is not a container isolation. Function app isolation is different, but it is pretty much, what it does in terms of packaging. Okay, so and right now when I try to run this project, you are going to see a console app pop up, which is going to host the func executable, which is the runtime. The runtime will go out. It's going to try to attach to my networking system, obviously. It is going to discover local functions in this project. And if they have an HTTP trigger, it is going to expose an HTTP endpoint where I can call this function. The first time we run this, it's taking a little bit of a while. And my computer is more slow when I am sharing my desktop, I suppose. Come on, please. This is just hello world. I'm even having a hard time to switch between windows. What? Hello? Okay. Let me give this another try. Most probably it is trying to launch the storage emulator as well in the background. Yes, there you go. Okay. Let me zoom in. So this is the HTTP endpoint for my function. I'm going to copy that, go out. I can open a browser window to send a simple HTTP request. I'm going to say, hey, name equals Darren, enter, and there you go. So currently this is running on my laptop. I didn't deploy it to anywhere, and I can see the logs in the background. So I'm able to test the function locally pretty nicely. Now let me stop that and go back to our slides. So we did discuss a little bit about triggers, and then we have this thing called bindings. So what did the trigger do? We had one trigger, right? HTTP trigger. We did talk about the events, right? Every time an event files, our code runs. So those triggers actually are bindings to events. HTTP trigger simply means, hey, there's an HTTP event, run this thing.
We have other triggers as well. For example, if you're going to have a timed job type of thing, there's a timer trigger. You give it the cron expression, like how frequently you want to run it, every Monday at 8 p.m. something, right? And then we use timer trigger to create an event. You can have a trigger that listens to the storage system, and when there's a file uploaded, you want to run it. I mean, at this point, triggers are kind of trying to help you to connect with different type of events. That's what they do, right? And then we have bindings. Bindings are, again, kind of trying to help you. You know, what is data binding? If you ever use a language with, connecting to SQL or something, data binding is about the programming object that you have in your programming language, and most probably the relational database that you have, right? And you are trying to connect these two worlds. You're binding that. Or maybe you have programming objects and user interface where you're going to bind a text box on a user interface with the backing, programming objects that you have. So that's what binding is. And in this world, what we bind is, for example, with the file trigger thing, let's say someone is going to upload a file, and then I want to run a function that scales the image. Okay, someone is uploading an image, I want to scale it to a couple of different resolutions, right? So I would actually build a function that will have a trigger into the storage system. Every time there's a file uploaded, I want my function to run. But I don't want just to trigger the function, I want to bring the file as well into my function. So usually what you can do is your function runs and then you go to the storage and read it, but I don't want to do that. I want the data to come in with a binding specific to the storage system. I mean, at this point, everything is about making the developer's life easy with the runtime itself, kind of providing a little bit more convenience, right? So that's what binding is. You can have a binding, for example, one of the common patterns is using a queue for jobs, right? You have an e-commerce website, let's say, you're getting orders, and you are not going to process orders real time. When you click the purchase button, it's not going to do everything when you click that button, synchronously. Otherwise, you will just wait for the website to charge your credit card to go and, talk to the third party, whatever provider. So there's a lot of operation happening in the background, right? So when you click the purchase button on, Amazon.com, for example, it tells you, like, we have created your order and now we will process, and then at some point we will let you know when we are done with the processing of your order. So something in the background is happening. So how that thing is structured on a higher level is when you create your order, a job is being put into a queue, and there are a bunch of workers, right, that are waiting for the queue and looking at the queue, and when it's a new job, they take it, they process it, and they put it into another queue or something, or they send you an email, right? And based on the amount of jobs that you have in a queue, those workers have to multiply and scale. So serverless is beautiful to do this because, we have a queue trigger. Azure Functions comes with a queue trigger that you can implement with the queue on Azure. And then when there's a new job in the queue, it triggers the function. It even has a queue binding where you even get the message in the queue as a text, as a parameter to your function. You don't even have to go to the queue and read what's in the queue as part of the content of the message in the queue, right? You don't have to do that. So that's another example. So those are called input and output bindings. You sometimes need output binding as well, because, for example, the case of resizing an image. You took the image as input binding, then you resize it, and then you're going to store it. So instead of you storing it, you can actually just simply return it as the result of the function. And if you have an output binding to where it is supposed to be saved, then the runtime will save us for you. Okay? So those are the things called triggers and bindings. So let me show you how that looks like. So the first thing I'm going to show is, it's pretty simple, the timer trigger. This is nice to do, things in an interval, some cleaning jobs maybe, I don't know, or a third-party system that is not going to reach out to you, but you have to check every 3 minutes, every 5 minutes, do some kind of a polling. So this is it actually, function name, function one, again, a C# function or whatever language you use. And then you say, hey, this is going to be a timer trigger, and I want it, this is a cron expression. This says every 5 seconds, I want this function to run. And then you put some kind of a code, whatever you want to do here, right? That's it.
So this thing, if I deploy this to Azure, this is going to run every 5 minutes. Whatever I do in it, it's going to do it, and I will only pay again for the time I used, the processors that I used. Cool. So the thing that I want to show you, and I did kind of talk about it, I guess. We did talk about timer triggers a little bit. Let's talk about the binding stuff. So this one is an example with the queue binding that we just talked about. So this might look a little bit scary at first. There's a lot of stuff here. You don't have to use all of that. But it's pretty simple, actually. Let's see. So I'm not sure why I'm having errors. Most probably this has to restore. Yeah, NuGet packages are being restored. It's going to, yeah, there we go. Cool. So this is a function. This is a C# function, okay? It looks like it returns a task message. What is a task message? If I scroll down, it's simply an object that has a property named text with the type of string. Crazy simple. Okay. So this function returns a task message. Cool. This is a function named function1. It has a queue trigger. It is going to listen to a queue named sample queue. The sample queue is part of a storage account in Azure. Storage accounts comes with file storage, blobs, we call them, with a queue system where you can have multiple queues and some other stuff, okay? This one, the connection, points out to a connection string stored in my config file. This is the key for the, config files are key value pairs. This is the key for the value of my connection string for the storage system. Okay, so what I'm simply saying is, hey, I'm going to have a queue trigger. The storage account connection string is in the config file, and it's named Azure Web Job Storage. And then I want you to listen for a queue named sample queue. Okay, that's pretty much it. The interesting thing is this one. So this queue trigger, that attribute, is actually assigned to a parameter of this function, and the parameter is called myQItem. The name is not important, and it's a string. So when there is an item in the queue, this trigger will not only be triggered, but it will bring in the value of the job from the queue and bind it to this string variable. So your function is executed, and as part of your C# function, as a parameter, you are getting the content of the job that you have been triggered, right, from the queue. Cool. So the other parameters are optional. So these are totally optional. You can see, the expiration time of the job. You can see when the job has been inserted into the queue. You can, next visible time, I'm not going to go through that. DQ count. DQ count is an interesting concept because if you take the job from the queue and for some reason you crash it before you complete it, the job will not be deleted from the queue. It's going to get visible again. And the DQ count represents how many times a job has been taken from a queue for a try of execution. You have to know this because if there is a job in the queue that you are trying to do more than, for example, 10 times, then there's no value in it. You have to stop retrying it, right? We call those poisonous messages in the queue. So the DQ count tells you that. And then in the function itself, we're not doing anything. This is just an example, right? But what we are doing is we're returning a test message out of this function code. We are returning an object of test message. I'm putting the myQ, the string that I got from the job. Again, this is just an example, right? I'm simply taking a string from a queue and then putting it into another one. That's what I'm going to do. But when I do that, I'm not returning the string directly. I'm actually putting it into a custom object that I created in my, programming language, right? The object. So how will this function know? When I return this object, what's going to happen? Who am I returning to? There was a job in the queue, my function ran, And from that function, I'm returning an object. Where does that object go? And this is about output binding, okay? Because I have an output binding here. And I say, hey, whatever is returned, put it into a queue named sample Q2. That's it. So I'm simply, right now, what I'm doing is, I'm listening to a queue through a trigger and binding, getting the data, processing it, putting it into an object, and sending it into another queue. And if you look at my code, right, if this had some business logic in here, if you look at the code, it would be like 99% business logic. There is no plumbing code. There is no, let's listen to the queue. Let's go to the queue, take the content. Let's reach out to another queue, put the content. There is no plumbing. Whatever you write in this function is purely what you want to do with the message, with the data that you have. And that's valuable because that means whatever you're going to maintain when you build this app is going to be your code. You will not be maintaining the communication that you have with multiple queues and stuff, right? Because that's part of the runtime. I'm not going to run this because I don't know how much time I have. Yeah, right? Okay. So I'm not going to run this. It works, trust me. The other one that I want to show you guys is the image resizing scenario we talked about. Let's look into it. I'm kind of going a little bit faster than the slides are supposed to because we don't have a lot of time to cover everything, but I still want to cover everything. So this is another function, obviously, right? So look at it. Look at it, because at this point, you should be able to figure out what's going on here. Let me scroll right a little bit. Maybe zoom out so that, yeah. This is all that you have to look for, okay? Because that explains, everything in the function in here. Actually, you know what? Let's look into the function. Let's start from here. Let's start from here. What does it do? It has a thumbnail width. Then it does some kind of a calculation. It does some kind of a resize and, it saves into an image small, which is what? A stream. Again, a C# object, in memory object. I have what is this? An image out of input, which is another in-memory object. So simply, this code is taking some image from an in-memory object, which is already in my hands. Then I'm resizing it. I'm putting it into another variable, right? I'm doing it again because, I'm lazy and I like to copy paste code. I'm resizing into 2 different resolutions. As you can tell, this is, again, this is, sample code that I write. It's not supposed to be high quality. Anyway, but if you look at the code, this is all about resizing based on in-memory image objects. This has nothing to do with Azure or anything, like if you look at the code that I write. Because everything is here, right? Look at that, blob trigger. Blob means not exactly, but let's go with binary large objects. That's where the name, that's not where the name comes, but it resembles and I like it. So this is essentially a file or whatever is being uploaded into the storage system. This function is going to be triggered. The storage system connection string is in this one. This is, let's say it's a folder. In this case, it's named container. So, and this one is going to be a variable that the runtime will understand. So simply, let's say if I put an image named, Darren.jpg in this particular container, this function will run. This name variable will be Darren.jpg, and the content of the file will be in this variable as well. So it will, because I have as part of the blob trigger, I have an input binding too. So when a file has been uploaded, so you have to be very careful, obviously, if you upload a 1 gig file, it's going to be a little bit scary because it's going to try to, read the full file. If you don't want to read the full file, you can simply change this parameter into string. It's just going to read the thing, or you can even do, even remove that and put an object or something. Okay, so we got the blob trigger, we got the content of the file. Then I have, these are output bindings. And I have two of those. I can have multiple output bindings. I can have multiple input bindings as well. Okay? So as part of this, I am actually going into two separate folders in the same storage system. I want write access. I'm using the same file name. And these are going to be filled in from these variables. So my code, when it runs, the runtime already, triggered the function and binded the variable input to the file that has been uploaded into the storage. So my code does the resizing and puts resized images into two variables. Then my code simply is done. Then because those variables have been, assigned to output bindings, then the runtime itself will figure out that, the function scope is completed. Now it's time to store these two variables into their, proper locations in the storage system, and that's it. Whew. Okay, let's give it a couple of seconds to let that sink in, right? And all the Chinese people can upload images. We don't have any problems with that. They can do it. It's kind of scary, right? I don't have any problems with Chinese. They're just, they have a big population. I like to use them as an example because of that. All the Martians. Doesn't make sense. Any questions? At this point, I'm sincerely not sure if that's a good sign or bad. Okay, go ahead.
You have explained some examples, so I just want to discuss a separate scenario. Like, for example, we have a Python Django backend. So we have multiple APIs. So if we want to, move it from conventional server setup to this serverless setup, so how would we, what approach would we take? Like, we have multiple APIs. So for each API, will we charge separately, or is there a way to, encapsulate everything and provide a serverless solution?
So your question is, for each API, will we be charged separately? We have, let me repeat just for the sake of, the microphone having you, right? So we have a Python app, you said. We have multiple Python APIs. If we host this in a serverless, in this particular environment, are we going to be charged separately for every API? So you're going to see a single charge on your credit card, if that's what you mean. But in the logs, you are going to see separate millisecond execution reports one by one for every instance, for every execution instance of every API separately. You are going to see a full list that's going to say order API. It's going to give you the HTTP endpoint. It's going to say API/order 200 milliseconds. It's going to say API/whatever 100 milliseconds, and it's going to aggregate all of that, and you will pay based on the total amount of time that you used, and it will aggregate the memory that's been used in those milliseconds that you use. So it's going to be totally separate. Yeah. Did I answer the question? Okay. Cool. Okay. Go ahead.
I have a question. Why Microsoft languages, like coding languages, are so complicated comparatively?
Compared to what?
Comparatively, like so complicated to understand or
Cool.
the coding languages, like C#.
Yeah, I'm trying to understand what language are you comparing to?
Python, JavaScript. If you compare C# with JavaScript, you can write, the same function with like 5 lines of code in JavaScript.
I don't know. Because honestly, I'm coming from a Visual Basic background. You're asking me why is C# complicated? God, I don't know. The developers want to, why do we have those weird characters in here? I was a VB developer. I don't know. I guess developers like to torture themselves. I don't know. Yeah, but again, Azure Functions has support for Python as well in this case, so you can use pretty much what language you want. It doesn't matter. I'm using C# because that's what I know. And those triggers and all that stuff, they have multiple different SDKs for every language, so you can benefit from those, even though the syntax will be different. You can use these features in those languages as well. Go ahead.
I have a billing related question as well, but it's kind of hypothetical question. If, for example, I have an instance and 100% of the utilization of that instance can run the function for 1,000 times. Would it cost, which doesn't make sense that the instance run on 100% utilization, I understand, but it's a hypothetical question. And if I ran that function on the serverless approach for 1,000 times as well, would it cost me less in the serverless approach?
Oh, there was a plot twist at the end. Would it cost me less? So let me roll back then. You have a function that has 100% CPU usage, and it takes, let's say, 5 seconds to complete.
It can run during the whole month. Let's say, for example, that instance cost me $150.
For a full month,
yes.
You have 100% CPU consumption.
Yes, and it can run the function only for 1,000 times.
And if you run it on the serverless,
yes.
Is it gonna cost me more or less? We have to calculate that. Because if you have, to be completely honest, if you have a usage that is static, like you are telling me you have 100% at all times, you don't have any needs around scalability, your usage is not fluctuating at all, so you're not benefiting some of the features of the platform, right? So in that case, probably the other approach would be much cheaper. Should be. I'm not sure. We have to calculate that. But ideally, you are driving a Mercedes, but you don't need it. Kind of situation this is. But again, I don't know because of political reasons. They might have priced differently just to encourage people use this one or that one. Sometimes there are changes. But if you're 100% used and you are not worried about any of the benefits that I just described, don't use it. I would kind of say yeah. In that case, it's kind of weird. If you asked me this question like 5 years ago, I would even say don't use cloud. Because there is this concept like if you go like 15 years or 20 years back, we didn't have it was a decision to buy a washing machine for our home. It was an investment decision, right? Is it worth it or not? Should we wash a hand or have a machine because it's a luxury? Then 10 years later, everyone has a washing machine at home because it got cheaper. So that's where cloud is going. Even if it's maybe made more sense in the past because cloud was expensive and stuff because it had all these luxury features. Right now we are going into that space that it's being consumed so much that those luxury features are not considered luxury, and it's like you can afford having even if it has features that you don't need, right? So that's where we're going. In the past, like 10 years ago, when I was talking about cloud, I was simply saying people, if you have a constant use, you might think of not using cloud at all. But right now, we're moving into a space where I can't say that. I can't say that. Yeah, interesting question.
So my question is simple. I just wanted to know, let's say, I have in this Crowley API world, I have the API and extends on kind of development stage. It's like a third API depending on a third-party API.
Yes.
Extracting some information out of it. So
yes.
Let's say the third API is not responding, or it's basically slow. So basically, I'm not using that much computation power on that serverless API which I'm renting out. So will that cost me for that delay even, or it's just like, okay, whatever like my function is doing whatever, I'll be charged for that, and then
yes. So you can start a thread, like a programming thread, right? And do nothing. You can block the CPU if you want to. You can write bad code and block the CPU and do nothing. You will pay for it. No one is looking if you are really doing something meaningful with the processor or not. So if I would say simply, thread sleep 5 seconds, they are giving me the processor and it's blocking the core. So it's dedicated to me. They're going to consider that this function has run for 5 seconds. It didn't do anything, it just blocked it, but you will still pay for it. So if you have a sequential, third-party call and you simply wait for it, Yes, you will pay for it. So that's why if they have some system like webhook, most probably the government agency never does that. But if they have a webhook, that's what we suggest is, go put your request and with that give an endpoint so that they can come back to you when they are ready. But again, I suppose they don't have that, right? That's not the way they usually, implement it traditionally, let's say. But yes. So this kind of makes really very important the optimization of your code. Because when you optimize your code, you directly see the result on your bill. And I love it as an engineer, to be honest. I love, things that are, there's, for example, in Azure, there's this database called Cosmos DB. I love it. Why? Because it's exactly pay per use. You pay for your query. Okay. Imagine a database where you pay for the complexity, depending on the complexity of your query. The processor you use, the disk I/O you use, the execution plan, and all that stuff is being considered. And if you fine-tune a query, you are going to start paying less. And to be honest, as part of the Cosmos DB, when you send a query in the result set, as part of the result set, you get your billing for that query. You get your unit of cost for that particular query. I love it. I'm in love with serverless stuff, to be honest. Yeah, I guess it shows. Okay. Did we have online questions, by the way? I don't want to.
No, not really.
I want to be fair. So online people are sleeping right now. Okay. Let's have that question as well. And then
one more question.
Yeah, one more and then finish because pizza is getting
Is there a
cold.
way to monitor the resources which are being provisioned for your code in the backend?
Yes, there is. You need to run a specific query. So there's this service in Azure called App Insights. That's the one we use to log our consumption of these functions. So we connect a function app with an App Insights account where all of these consumption logs go. And there you can actually see how many servers actually spin up in the background. It's just, to give you more visibility. It doesn't affect your billing, by the way, because that's not how you are being charged. But just in terms of, debugging something, an issue maybe, I don't know, you want to see, you can see it.
And is there a way to control that as well in terms of provisioning?
No, there are different deployment models. The deployment model that I discussed so far is called consumption plan. You can definitely say, come to Azure and say, I only want to have 3 servers and I want to run my functions here. I don't care whatever you do. Don't scale my thing. You can do that if you want. You can definitely do it. On the consumption plan, which is event-driven scaling, what you can do is you can put a limit with gigabyte per second unit. You can say, hey, I only want to have 10,000 gigabytes seconds. So that's the limitation you can have. But if you really want to have specifically a server level limitation, then you're going to need to own the cluster. And then what you do is you come to Azure and say, hey, give me 3 VMs, a cluster of 3 VMs. And then when you are deploying your function app, instead of deploying it to the consumption plan, you say, hey, I have a 3 server cluster here. I want you to deploy it there. It will still scale in it, but it's not going to add servers because that underlying level is that control plane is in your control. You can do that. Cool. Okay. One slide. One slide. Nothing more. Don't look at me like that. Just one slide so that they can grab the slides if they want to. So the code, the samples that I used are there. Interesting. I didn't put the link for the deck. So if you go dex.darren.me, you can get the deck as well. And the sample code is in there on GitHub. That's all. Thank you. Thank you. Oh, I have actually swag. So, okay, let's do this. The last person who asked a question. Catch it. You can get it. Okay. Previous person. Who was that? Previous person who asked a question. Okay, I have something for you as well. For all others, if you are a fan of laptop speakers like I am,
we have a serverless laptop sticker that you can grab from here.
I'm gonna leave it here. Don't grab all of it. Just get one, okay?
And for you, I have another small gift. If you come here, I can give it. Otherwise, I will just take it home. Okay. Okay. That's it. Pizza is outside.
When pizza is this side, quick reminder, make sure that you are part of the community on Meetup. As Darwin said, we got some little swag here, but we couldn't bring everything here today. But we have a session tomorrow, part of a series that we are doing with Azure Cloud. It's a tech hub here in Dubai. We have the academy in Al-Quds. So tomorrow they are doing a session on microservices. Last month we did. So every month we're doing something together. And I've got loads of swag there. So if you come tomorrow, I try to make it up with some really nice pizza and try to accommodate everyone's taste. So you will have that after the session. And we try to block some time. So I really apologize if you also have a class after this. But if you don't, just take your time, enjoy the pizza, enjoy the soft drinks, etc. Be part of the meetup. Next time I will try to make sure that we get the swag up to here. But the best you can do tomorrow, if you are available, it's an Al-Quds, 6:30. Be there. I got loads of swag stocked in the storeroom there, so I'll make sure that you get some. And yeah, did I miss anything?
Perfect. Thank you so much, Hussam. And this is a great motivation for I in fact like the idea of giving the goodies in the next session so that we can invite everyone for the next session as well, which is going to be tomorrow.
I definitely couldn't have arranged for everyone, honestly. It's been a great audience, a great attendance, both online and in person. I think we crossed the 100 by far.
More than 100.
So again, I wouldn't even been able to bring them here. So let's do it tomorrow. And make sure you're part of the meetup so that you don't miss on any of the online and